Today's video is being lubricated by S'more Scout S'mores Stout from Kilter Brewing in Winnipeg. They actually brewed it with marshmallows, cacao nibs, graham crumbs, smoked malt, baking spices, milk sugar, and vanilla. Wow, that seems like a campfire experience in a glass. Not sure I can taste the marshmallow. The chocolate and everything else is definitely there though. Cool. So do you remember this thing from the last mailbag? It describes itself as a dynamic microphone preamp fire. So what this is supposed to do is add about 28 dB of gain, of nice clean gain to a microphone, so that a really low-level microphone can be boosted up for long lines or quiet speakers or just weak microphones or whatever. There's all the specs in the manual. Not too much to say about it really, other than the gain, frequency range, which is, your basic, what you would expect for speech, although flat within 0.3 dB across the entire audio spectrum. That's an impressive specification. And of course, those who remember from the mailbag will remember that there's one specification that's not listed here but is on the website. And that mystery specification is the sex to noise ratio. Doesn't mention anything about that in the manual for some reason. So the reason I grabbed this thing, I do have a couple of older dynamic microphones, one in particular, this one, which I would like to use. This thing is kind of got a weak output. It still sounds okay if you give it enough gain, but when you boost it up with in software, there's a lot of extra noise comes into it. So I'd like to see if this guy could do the job. But for my initial testing, I'll probably just use this one just because it's more convenient. And I know it does work. It's got a reasonable sound and a reasonable output level. So it'll be a good first test. And then at the end, we'll pull out the old Shure and see how he sounds. So this thing doesn't need any batteries. It is powered on the from the input connector from what's called phantom power. Phantom power is basically a way of getting a 48-volt DC signal superimposed onto the audio signal in a way that doesn't interfere with it, because some microphones, condenser microphones most notably, which is the one I normally use over at the computer, require 48-volt power to the microphone to power the built-in preamplifier. Other things, DIs and a few other devices also use phantom power, but condenser microphones and DIs are the most common. And since my audio interface on my computer, or that's connected to my computer, does supply 48-volt phantom, we should be able to use that. So just for reference, here's the condenser microphone that I've got connected to my computer for recording. It's not the most expensive microphone, but I think it sounds pretty good, especially for the really cheap price I paid for it years and years ago. And it is connected through my M-Track audio interface. It is being powered by phantom power. And now we'll just quickly switch microphones. Okay, now this is the handheld microphone. I've got it a little bit closer to my mouth. I've had to crank up the input level on my audio interface a little bit more, but it also sounds pretty good. Although you'll notice that even with the input level cranked up on my interface, as I said, the level is not quite getting as high as it was. Unless I get really on top of the microphone, and then you should be able to hear the famous proximity effect of a dynamic microphone. So now I will hook up this guy here to the microphone with phantom power on there, as I said before. And after listening back to those three recordings, that is disappointing. To me, it sounded like absolutely nothing. I was screaming into the microphone at one point, and I could not hear any voice coming through. So, either it's damaged or it's a piece of shit design that I never should have bought. And, well, I guess let's open it up and find out. I need a smaller screwdriver than that. So these screws in here are like the old Switchcraft connectors. You screw them in, they're a little set screw, you screw them into the connector, and it goes down below the barrel so that you can slide the barrel away from the guts. So, well, that's not a good start. Only 2 wires. Oh, and that ground is just kind of clamped under there. Wow. Okay, what's down here? That is a lot more simple circuit than I was expecting. We've got a capacitor, 2 resistors, a transistor, possibly an IC and a transistor package, but probably just a transistor. 4 components, and they've strapped one of the signal wires and the shield ground pin together. Yikes, that's not right. What's going on at this end? The shield ground and the shell are connected together. That's good. And the other 2 pads are separate, connected to the circuit somehow. So it looks like they've unbalanced the audio at the input side here, and it may or may not be balanced at the output, but I don't think so, because you'd need 2 amplification devices to create a differential signal to create that balanced output. I'm going to clean off some of this schmoo here to see if I can get part numbers, and I'm going to figure out what this thing is. I'll be back in a minute or two. So after a bit of digging around, they have actually put the component names on the board, which is helpful. So that transistor is a 9014. This resistor is 150 ohms. And this one over here is 200K. This capacitor, the electrolytic capacitor, is a 1 microfarad, 50 volts. And since Phantom is 48 volts, I guess technically that meets spec, but just barely. And then there's a little ceramic capacitor hidden underneath it that's not labeled, although the footprint shows that it could be an electrolytic or anything. 5 components. Wow. So here's the schematic of this simple little thing. We have the input XLR. On XLR connectors for audio, pin 1 is the shield ground on the cable and is typically connected to the shell of the connector too, but not always. It doesn't have to be, but typically it is. Pins 2 and 3 are the balanced audio pair. And also for phantom power, pin 1 is the DC ground, and pin 2 and 3 both carry the same 48 volt power signal. But that will be coming from this end, this guy here. Anyway, so the input from the microphone here, pin 3 gets grounded to the shield, and so that carries on as the black wire here. The red wire comes off pin 2, goes through the 2 capacitors which are in parallel. The little surface mount capacitor, which who knows what capacitance it is, and the 1 microfarad capacitor. So a DC block happening there. I guess that's good, and then it's passing the audio through the 1 microfarad capacitor to the base of the transistor. The collector of the transistor connects back to there through a 200K resistor. Okay, fine. The emitter goes down to the common ground through a 150 ohm resistor. That's all the components. And then the collector of the transistor goes out to pin 2, which is half of the audio pair. The ground path continues on to pin 1 and the shield. Notice anything missing? Pin 3, which is half of the balanced audio pair, does not have a connection. It's soldered down on the pad on the board, but that pad has no connection to any other solder point anywhere on the board. So while we are getting our DC into the circuit through pins 1 and 2, so there is 48 volts across this transistor, which again is rated for 50 volts, the audio pair can't get out. I suppose technically, if you were to take the ground up to pin 3, then the audio no, that wouldn't work because that would create a DC short in your Phantom. There's no way this thing could ever work. I mean, it looks like a single transistor amplifier, except for it goes nowhere and does nothing. I'm going to go and look some things up while I regain my composure. Hang on. So what this cheap piece of crap is trying to emulate is a Cloudlifter, which is a fairly well-known piece of equipment in home recording and maybe in recording studios. I'm not sure about professional recording studios. It's got a sort of a mixed reputation there, and normally you can get enough gain out of the board for that purpose. But a lot of people are using it when they're doing podcasting and stuff. You notice the SM7 back there. That is a super common podcasting microphone these days. It's historically a broadcast microphone, but so a lot of podcasters these days are using these things to boost up their microphone just for whatever reason if they can't get gain anywhere else. The specifications are surprisingly similar to what the AliExpress listing was showing, only in this case it's probably more honest. The frequency range is completely ridiculous. That is, subharmonics that nobody can hear. You can maybe feel it in your groin. And 80 kilohertz, the dogs could hear that, I guess. Normal human hearing is in the 20 hertz to 20 kilohertz range is what it's normally called out as. So this is, exceeding that. So multiple places, Cloudlifter talks about their patented ultra clean circuitry. So being patented, I was able to look it up on Google Patents, and I found the circuit, which looks absolutely nothing like the one that we got in front of us on the workbench. So there's various different schematics that they've got listed on their patent application, but typically they are using 4 JFETs to boost that balanced audio. And JFETs are a much lower noise, higher gain transistor than a common BJT, which is what's in this thing. And they even call out what the transistors are: SK170 and SK117. That SK117 is an N-channel junction type field effect transistor, a JFET, which, as I said, is a higher gain, lower noise type of transistor than a normal BJT. You can read all about them in the Wikipedia article that I'll link below if you'd like. Unfortunately, I don't have any of those around here to build up this circuit on my own. I may order some. I might go down the rabbit hole a little bit further. I'm not sure if it's worth it just to get an old microphone working. Maybe it is. At least I've got a container that I could put the circuit in. A bit more searching around, I found this schematic as well, which is from an Alcatron MA1 preamplifier. It is almost identical to the Cloudlifter schematic. I don't know if it's suspiciously similar or if it's just something that was come up with independently by somebody that's good at reading data sheets. Also digging around online, I found somebody who'd opened up Cloudlifter, a legitimate one, and taken a picture of it. So it looks like the modern ones anyways are using dual JFET packages in chips, probably, and then just 1, 2, 3, 4, 5 resistors and 2 capacitors. It's still a nice simple circuit. At least that's what appears to be on top. If this is just a single-sided board, I don't see any vias, so it probably is. So I guess let this be a warning to anybody watching or anybody who has searched and found this video, that if you see something that looks like this, it's just got this junk inside it and it's not going to do the job. Save your 20 bucks. And if it's not on sale for 20 bucks, don't even think about spending the 60 that they normally charge for it. That is ridiculous. Anyway, quick little video. Thanks for watching. Questions and comments down below. I'll talk to you later. Oh yeah, and Dustin, you were right with your comment on the other video.